This is your reality check.
Hi everyone, and welcome to The Reality Check, the Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. I'm your host, Darren McKee, and with me, as usual, is Adam Gardner.
Hey, what's up, Keyboards?
We have a great show for you today. Adam is going to explore why classrooms always have windows on the left-hand side.
That's right.
But first, is our solar system windy?
What? Solar windy?
The other day, I was watching a clip on social media where two comedians were bickering over whether there is wind on the moon.
Okay.
And that made me wonder about which parts of our solar system experience wind at all. So that's what I'm going to explore today. But first, addressing a classic in skepticism, when astronauts planted the flag on the moon, it looked like it waved. For decades, that single image has been a tiny puzzle. How could fabric ripple when there's no air?
Well, it can
Must be
ripple.
because it was fake. I kid. But the flag didn't wave because of wind. Before we start our tour of windy or windless celestial bodies, let's start with a plain definition. We know I like my definitions. Wind is bulk motion of an atmosphere. I know you say that to all your friends.
Okay.
It's air or gas moving from one place to another because of pressure differences, heating, or rotation. On Earth, we feel it as a breeze, a gale, or a hurricane. But the same physics that can create wind needs enough gas to behave like a fluid. If a world only has a whisper of gas, molecules don't collide enough to make a flowing wind. Instead, you get particle streams, plumes, or, well, nothing at all.
So is a world with less gas more likely for it to be static? Is it in less
By
motion?
static, you mean less wind, yes. Not static, electrical, chemically, but
No,
depends. Yeah, correct. So let's go through a bit of our solar system, starting with the Moon and Mercury. They are, we'll say, the minimalist members of our tour. Both have essentially no atmosphere. Only an exosphere so thin it's almost a vacuum. That means no weather, no clouds, no gusts, no wind. What moves on these surfaces is not air, but particles. Micrometeorites pepper the ground, solar particles slam into atoms and sputter them away, and tiny dust grains can hop short distances when electrostatic forces charge them.
Wow. Cool.
Yeah. Now that Apollo flag, like I wasn't going to give you the answer, looked animated because astronauts twisted the pole into the ground and the fabric kept its motion in a near vacuum.
Yeah.
It's a human moment that teaches a scientific lesson. Motion doesn't always mean wind.
But the reason for which the flag kind of stayed upright was because there was a rod across the top, right?
That's correct. Yeah, so if you picture like an upside-down L-shaped type thing, there's a rod going into the ground and then across the top. Going to the other extreme, Venus is a world wrapped in thick, heavy carbon dioxide atmosphere. The strangest thing there, for our purposes, is superrotation. The upper atmosphere of Venus races around the planet far faster than the planet itself spins.
What?
Imagine clouds circling a world in a few Earth days while the surface crawls along. So those cloud-top winds are relentless and global. They're driven by thermal tides, waves, and complex momentum transfers. Venus's winds are not gentle breezes. They are basically planetary scale conveyor belts.
Wow.
That's a whole lot going on Venus.
Cool. So if you lived in the atmosphere of Venus, it would just look like the ground is flying beneath you and you would be somewhat like static in the air or something like that.
I think we need some interstellar music for a visual here.
That'd be cool. And you wouldn't be able to breathe.
But yeah, you'd have a lot of problems. Not just that, but yes. Yeah. Earth, where I bet you are listening to this right now, provides a bit of a baseline condition for comparison. We can't help it. It's what we know.
Yeah.
Uneven heating from the sun, the Coriolis effect from rotation, and pressure differences make our weather. We get everything from pleasant seaside breeze to jet streams that steer storms across continents. But you know this as you live here. So, moving on. Mars. Mars has only about 1% of Earth's atmospheric density, but that thin air still moves. Martian winds can whip up dust devils and even planet-spanning dust storms that darken the sky for weeks. Because the air is thin, each gust carries less force, but dust is light and easy to lift and move around. Over time, those winds sculpt dunes, coat solar panels, and even end missions. Mars provides a useful lesson. Wind's power is not just about instantaneous force, it's also about persistence and the ability to move fine material.
Now, I'm guessing with 1% of our atmosphere, wind power would not be viable on Mars compared to solar.
I think that's true. Now, solar is more viable, right? Because we actually have rovers that use solar power.
Sure.
We get further away. But yeah, I think the wind is not going to do much there. Now, I mean, humans are very creative. So it could be we come up with some apparatus that can get more than it takes to like create and give, right?
Yeah.
In some ways. It's like, how much power do you need? How can you access it, right? Well, before getting to the 4 gas giants, let's look at some of their moons. Titan, Saturn's largest moon, is the most Earth-like weather system in the outer solar system. It has a dense nitrogen atmosphere and a methane cycle that plays the role water does on Earth. So that means on Titan, it can rain methane, rivers carve channels, and lakes collect hydrocarbons. Winds there shape dunes and push clouds across a hazy orange sky. The chemistry is alien, but the behavior, clouds forming, rain falling, dunes, would feel little similar to anyone who's watched a storm roll in.
Cool.
Not every moon with activity has global winds. Enceladus, Saturn's icy moon, and Io, Jupiter's volcanic moon, for example, are dramatic for other reasons. Enceladus, correct me on pronunciation if you'd like, listeners, shoots cryovolcanic plumes from its south pole. And yes, cryovolcanic means ice volcano.
Wow.
So,
Cool.
Alternatively, Io spurts volcanic gases from intense internal heating. Those are local violent flows, jets and fountains, rather than planetary weather. So those are kind of two opposites. You got your icy and your hot there. Triton, which is a moon of Neptune, and Pluto, no longer a planet, show seasonal sublimation. Frozen ices turn to gas and briefly create thin atmosphere and local breezes.
Now, those are probably not water ice because the water ice would be frozen all the time. It's that far away.
That's about right, yes. These are episodic surface-driven phenomena rather than the steady planet-wide winds.
Cool.
Now, that nice gentle breeze, keep in mind the surface temperature is minus 235 Celsius.
Wow. Okay.
So you're right, Adam. I think water usually freezes at minus 235.
I believe so, yes. Fact check, true.
Well, you know, with pressure does have a factor here. What about the gas giants? Well, there are the big ones, you know, Jupiter, Saturn, Uranus, Neptune. These planets are mostly gas, and their atmospheres are deep and dynamic. They host powerful jet streams, different flows of energy here and there, and storms that dwarf anything on Earth. The famous Jupiter's Great Red Spot is a storm that's larger than Earth and has persisted for centuries.
Wow, that's intense. I hear there's also some flower hurricanes on Jupiter.
If you're on Jupiter, I think it'd be more legitimate to complain about the weather.
Absolutely.
Like, you see that storm the size of Earth that's been going on for centuries? Tell me about it. You betcha. Oh, yeah. Wind speeds on these worlds can reach hundreds of meters per second. And those winds are windows into the planet's interiors, how heat escapes, rotation, organization flows, and chemistry and magnetism interact. Well, it's learning about science great and fun, right? So, as I just hinted, though, does this matter? This ends our breezy tour of the wind in the solar system, but why should you care? Well, because wind tells us about a world's atmosphere, its climate, its geology, and even its habitability. A flag that didn't really wave taught us a bit about vacuums. Venus's superrotation challenges our models of atmospheric dynamics. Mars's dust storm teaches engineers how to build resilient machines. Titan's methane rain expands our imagination of what a hydrological cycle can be. And the gas giant storms remind us that planetary weather can be both beautiful and terrifying. So next time you step outside and feel the breeze, think about the many faces of wind across the solar system, whether it's absent, local, savage, or global. Stay gusty, my friends.
Excellent.
Children often learn about the solar system in classrooms, unless they're staring out the window and daydreaming, which is always on their left side. Adam, is that true? Are windows always on the left side?
That's a good question that I never thought about until recently. Think back to your time in school, or if you're a teacher. Maybe that's not that long ago. From a student's point of view, facing the front of the class, were the windows on your left side? I saw this video on Instagram. It's one of these, hey, I'm going to blow your mind type of things. It kind of did blow my mind. So basically, something says, and I quote, I experienced my entire childhood and I've never sat in a classroom with windows on my right side. Well, then some teacher comes in and he said his mind was blown by this because he walked around his school and every single room was like this with the windows on the left. Even the rooms that he expected to be a mirror of the rooms on the other side of the hall, they were still on the left. They were just arranged like that. So what's the deal? The video doesn't answer. It just like poses a question, wants you to wonder about it. It's like engagement for engagement's sake without teaching you anything. So, Darren, if you think back to a few classrooms from your youth, do you remember what side the windows were on?
Loosely. When I think back to elementary school, I do have memories of it being on the left. Mm-hmm. In other classrooms, it wasn't as much of a traditional desk setup. So there might be a group of people sitting at a table.
Yeah.
And that would mean they would usually have like a bit of an orientation towards the front, but that would mean there's two perpendicular things, meaning if someone's facing forward, someone else would be facing like to the left or the right.
Yeah,
so there's going to be high variability there. There's definitely at least one classroom where it felt like the windows were behind me.
Yep.
But it wasn't just because of that table, but in terms of the orientation. But that class, I think, also had blackboards on two different sides.
Yes, so they probably changed the orientation of that room. They might have. So I was thinking about like what I can remember for windows. In kindergarten, there's no real front of the class. There's like kind of just desks, so that doesn't apply. My first and second grade class were the same one, and the windows were on the left. For sure. In third grade, there were two fronts, so it depends like how we faced. So the windows were on the right and back, or the left and back, depending on the orientation. I think in this case and a lot of other cases, there were probably, because there are blackboards on two walls, there was probably like designed to be a front. And then the teachers just decided, hey, let's switch things up, and they moved the desks. So now all of a sudden, so that can explain why sometimes there might have been a window on the right. And when there was, it's because there's a window on the right and the back, because we weren't really facing the same front that was designed, right? When I was in fourth grade, I was in a portable. So they had a different orientation. They were mostly on the left or in the back, and it depends how I faced. Fifth grade, I was in a portable, and those windows were on the right side. So that one is inconsistent, but maybe the portables didn't have the same design. I moved to a new school for sixth grade. Windows were on the left in sixth grade. In seventh grade, I started in a makeshift class that was on the stage connected to the gym. There were no windows at all. It was a bit of an odd experience. And then the year ended in a portable, and the windows were on the right side in that point. In eighth grade, we moved around the one classroom that was in the main building. Windows were on the left side. And the other classes were in the portable, and I can think of 3 that had windows on the left. So I don't know if it was consistent, but a lot of the portables did have those.
Seems pretty mixed, though, from all those examples.
Yes, it's mixed, but it leans a little more left. High school's class by class. Most of the rooms I was in had no windows. Some were like in the back, some were on the right, some were on the left. So I don't think I have good data on high school. It was an older school. It was built in 1971. It might have been like built by a hippie or something, trying to, eschew tradition or something like that.
Hippies are known for their construction.
Just like people trying to do different stuff. The school's got a new wing now. I drive by on my morning commute. I see the school. I haven't been inside in over 25 years. I don't know what the classrooms look like in the new wing. I don't have really reliable data on high school. University is mostly windowless lecture hall, so I don't have data on that either. My kids are in school. I go in for parent-teacher day. I don't even know where the front of the class is sometimes because we're like at the teacher's desk. So I don't have data for that. So it's a mix for me. It leans left, is not universally true. So maybe when you think about it, it seems mostly true. But for this teacher's example, it wasn't a fluke, because every single room in his school, right? So this seems to be a thing. So I found a Reddit post in an anime subreddit and a post on an anime forum asking why in anime shows the windows are always on the left side. So not only does this seem to be true where I grew up in Canada, but it seems to be true on the literal other side of the planet in Japan.
I don't know. Seems like some nice simulation bait, Adam, for you specifically.
Maybe. So this practice holds in a country where the writing direction and driving side of the road are the opposite of ours. So, we can't tie it to that. And thinking of a few examples, which I know well enough from memory, this seems to track. So obviously the point of view of school scenes in TV and anime may be facing the students if we're watching them and their faces talk. But the windows are often, on the right side of that shot if you're facing the students, or left side if you were a student facing the front. Sailor Moon always has windows on the left side, both the anime and the manga, if it's not flipped. The original anime and Crystal both had this, as well as the live action series portraying the Juban middle school or high school, depending on the season or the arc. Evangelion and Gunbuster, they have windows on the left side in those schools. It's kind of funny because these aren't real classrooms, they're drawn. So I wonder if the people who designed these scenes intentionally understood the precedent, or if they just based them vaguely on their own classrooms that they remembered from their life, or on real classrooms that exist, right?
That's a good question. I mean, if it's a Japanese classroom, they might, based on their own personal experience, if they're Japanese animators, but often animators will take field trips, so to speak, and visit other countries, and they might be like, oh yeah, that's what it is there. Yeah, so they just sit there and they sketch the classroom they're in, and it happens to be like that. I also saw a post on a cinematography message board asking why windows in classrooms in film are always on the left. And they were asking because of the particular way it lights the students' faces, right? So it would light the left side of the student's face. There was no answer on this post, and it's funny because they look at the question from a completely different direction, which is the light exposure, as opposed to where the actual window is, because they
Everyone's got their own way of looking at the world, right? So what's the deal? It is actually intentional and it is practical.
What?
Most students are right-handed. When they write notes by hand, which is a thing that people used to do in classroom, windows on the left side meant that the shadows are cast to the right of the hand, allowing you to see what you're writing, as the pencil is held facing the left. Windows on the right would mean that light would come in from the right, casting a shadow over the part of the paper you're looking at while holding the pencil in the right hand. This practice dates back to the late 19th century, so it's been around for some time longer than any schools I've been in, for sure, longer than indoor lighting and things like that. So modern classrooms have indoor lights, so the page is illuminated from lights that are kind of on top of you, either way, no matter where the windows are. But when the sun shines brightly, especially if it comes directly into the classroom, it will overpower the natural lights in that room. Teachers may also opt to leave the lights off if there's a good deal of natural light. If it's a nice day, you don't really need the indoor lights. It kind of makes a more chill atmosphere. So I would have thought that windows in the back might be better, but then your body would be casting a shadow on the paper, so that might not be ideal. It might be harder to read if the light's coming from behind versus from the side. Might get a more even distribution, and all things being equal, left is better than right if it's going to come in from a side.
How sinister of these designers.
I know. So other aspects of classroom designs are intentional, like the teacher's desk is in the front where the students face, and the door is also usually near the front so that the students can't leave without the teacher seeing it. And I think it kind of needs to be said that like a lot of there's this modern trend, like you mentioned, Darren, like sometimes they'll put kids in groups and stuff like that. So I think a lot of people try to reinvent the design of a class to try different things. So sometimes this doesn't really apply, but if you have a very traditional classroom, and it's designed in that traditional way, that's how it's going to be.
I don't have any memories of shadows writing ever. Now,
no,
I'm sure
you wouldn't notice if it didn't cause a problem.
Right. Or there might have been some issue I just never thought about much.
Yeah. So maybe if they were on the right, you'd be like constantly annoyed and trying to turn your paper a bit or something like that.
I mean, it would have to be like really bright light that leads like in a way like a very strong shadow that I have trouble seeing my pencil, I guess.
Well, if there was no lighting, like if you're talking about like it's 1895 and it's just like whatever.
I'm aware of that, but I was thinking in my school time we had indoor lighting, of course. So
I'm thinking back in Avonlea or something like that, Are classroom windows always on the left? No, but they often are, and this is intentional. The reasons are old, and while this practice may not be as necessary in the modern age, it still generally continues, and since the sun still shines and students at good schools still write on paper, the reason for this practice being the way the hand's shadow is cast on paper still applies. Sucks to be left-handed, but you should have thought of that before you let the devil dictate your sinister dominant hand.
Oh, wow. Listeners, write in with your left hand. That's interesting, Adam. I was wondering what the explanation would be. I did think about like the handedness of the teacher, but it didn't seem to matter that much once I flipped it. Like, well, the teacher can just write from the other side.
On the blackboard.
Yeah.
Oh, that could be it too.
Well, maybe, but like how much light is getting in? Like how big are the windows in this classroom, really?
Yeah.
Right?
Yeah. So now the shadow would be cast past where the teacher is writing, right? So it could be a mild effect for that.
What happens when the sun's on the other side?
Well, there's no window on the other side, so you don't see it.
I'm just sassy. You're like, well, light still diffuses in because it's the earth.
Yeah, I imagine some of the older, like, one-room classes might have just had windows on both sides or something like that back in the day.
Listeners, please write in if you actually have feelings about this, because this is a quirky one. It's an interesting one.
Yeah.
Well, thank you, Adam. And thank you for joining us once again. I talked to you about the windiness of our solar system. There isn't wind on the moon, but there is in some other planets and places. And Adam explored why windows are often on the left side in a classroom. Until next time, think better to act better.
Peace out, cuboids.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at TRC_podcast.
Outtakes.
Image of flag on the moon.
Just look up the opening scene from Independence Day. It's because of the alien mothership that it ripples a bit. A little moonquake going on.
Yep, you're right. So
There's a rod.
Yep.
And rod
I mean,
we trust.
Okay. Are you ready?
I was born ready.
That's not true.
It's never true.
Let me know when you're ready. So,
I'm thinking back in Avonlea or something like that, you know? Not a real place. I went to the fake Avonlea. It was pretty cool. Lots of Japanese people. Is that racist? I don't know. Okay, I'm at my closing here.
good stuff. Be Christina.
All right, that one's shorter.
Yeah, that was good.